Let me introduce our group members. This is our group members. Our captain is QAYYUM AKMAL bin ALIAS, and the others is AHMAD FARRIS MUQRI bin AHMAD YUZI, Muhammad HAZIQ MUQRI bin AMRAN, Muhammad HELMI ZULQARNAIN bin RAMIZU, Muhammad NABIL HAKIMI bin HANAFI. Each of us bring unique strengths and perspective to the team. Hi, I want to talk about gas chromatography. This is one of the experiment in CHM260. What is gas chromatography? Gas chromatography we use to separate volatile compounds based on boiling point and polarity, or tell us a gaseous mobile phase and a liquid solid stationary phase. Common carrier gases: helium, nitrogen, hydrogen. Widely used in pharmaceutical, environmental, and food industry. Produce chromatogram for identification and quantification.
We move to the objective. So for the gas chromatography, we have 4 objectives. So the first one is to determine the retention time TR of N-butanol and 2-propanol. To identify the component present in a standard mixture based on the TR. And then to identify the component present in an unknown sample. And lastly, to determine the effect of temperature on TR and RS.
Now, let me explain the methodology of our gas chromatography experiment. We follow a systematic setup to ensure accuracy and consistency in the result. First, we prepare 4 types of sample: pure 2-propanol, pure N-butanol, a standard mixture containing both compounds, and an unknown sample for identification. The instrument we used was a gas chromatography equipped with several critical components, each playing a specific role in the analysis. For each sample, we injected a small volume into the gas chromatography. The instrument recorded the retention time, which is the time each compound takes to pass through the column. We then compared the retention time of each peak in our chromatograph to identify the compound, including the components in the unknown sample. Lastly, we verified the oven temperature to study its effects on retention time and dissolution. Let's briefly walk through each component. First, carrier gas. This is an inert gas such as helium or nitrogen, which pushes the vaporized sample through the column. Second, injector. Here, the liquid sample is instantly vaporized and mixed with the carrier gas. Third is column. This is where the real separation happens. The compounds are separated based on their boiling point and polarity. Then we have oven. The oven controls the temperature of the column to optimize separation. Then we have detector. It sends the compound as they exit the column and convert that into an electrical signal. And lastly, we got data system. Finally, the signal is processed and displayed as a chromatography analysis.
Alright, so this is the results of this gas chromatography experiment. So, for the first slide, propanol. This is the chromatogram for the pure propanol example. We observed a single peak at 2.724 minutes. Since only propanol was injected, this retention time is used as a reference for identifying propanol in future mixtures. The clean, sharp peak confirms good separation and no contamination. For the second slide, which is the butanol, which is the pure sample. This chromatogram shows the result for pure butanol. The retention time is 6.043 minutes, significantly longer than propanol. This confirms that butanol has a stronger interaction with the stationary phase, causing it to elute later. This retention time will be used as a benchmark to identify butanol in mixtures. In this slide, For the first standard mixture run, we observed two peaks at 2.692 and 5.093 minutes. The first peak closely matched the retention time of pure propanol, and the second matches butanol. Although the retention times are slightly lower than the pure standards, the elution order is the same, confirming the presence of both compounds. For the second run of the standard mixture, the peaks shifted to 2.269 minutes and 3.294 minutes. This suggests the GC or the gas chromatography conditions such as temperature or flow rate were different. However, the elution order, propanol first, followed by butanol, remained consistent, allowing us to identify the compounds with confidence. For the last slide, which is the unknown sample. In this unknown sample, two peaks appear at 1.952 and 2.225 minutes. Even though these retention times are much shorter than previous run, the elution order is still the same. Based on the pattern, the first peak is identified as propanol and the second as butanol. The lower retention times indicate a higher column temperature or faster carrier gas flow during this run. We already analyzed the GC results just now, so we are going to get down for the discussion. First of all, we examine pure propanol and butanol samples, a conventional blend of the two, and an identified metronome in this gas chromatography experiment. By comparing their retention durations, which is RT, to establish benchmarks, the components in the unknown were to be identified. Pure butanol displayed a peak at 6.043 minutes, while pure propanol displayed a single peak at 2.724 minutes. The reference retention times were these values. The measured RTs in standard mixture run 1, which is the first one, were 2.692 minutes for propanol and 5.093 minutes for butanol, suggesting minor shifts that might have been caused by variations in the ejection volume or sample matrix while keeping the same elution order. For the retention times decreased even further in standard mixture second one, falling to 3.294 minutes for butanol and 2.269 minutes for propanol. These differences suggest that the temperature along with other GC operating parameters may have altered, impacting the rate at which the chemicals eluted. Propanol always eluted before butanol, maintaining the same sequence of elution despite the variance in absolute timings. The chromatogram of the unknown sample showed two peaks with the shortest retention duration found in this experiment, which is 1.952 and 2.225 minutes. Since these retention times are much lower than those of the standard mixtures, it is likely that the column temperature and the other GC parameters were higher than in earlier trials. Effect of column temperature or retention time and peak resolution. Maybe increasing the column temperature causes compounds to elute faster, reducing their interaction time with the stationary phase. This results in shorter retention times, but it may also reduce peak resolution if peaks elute too closely together. And if decreasing the column temperature, it will cause compounds to elute more slowly, which generally improves peak resolution by giving each analyte more time to separate. However, it also increases the total analysis time.
In conclusion, gas chromatography is an effective analytic technique used to separate and identify volatile compounds based on their boiling point and polarity. Each peak in the chromatogram represents a compound, and its retention time allowed us to identify it by comparison with a standard. The area of each peak also helped us estimate the compound concentration. Additionally, the temperature of the GC columns play a crucial role in separation qualities. Using temperature programming helped to separate both low and high boiling point compound efficiently. Overall, GC is a powerful tool used in various industries including pharmaceutical, environmental science, food safety, and forensic analysis. It is reliable, sensitive, and capable of handling complex mixture with precision. This is all from us. Thank you for watching.